Here we're going to solve a system of nonlinear equations algebraically. As before, when we solve systems algebraically, we could use the method of substitution or elimination. Because this second equation here is already solved for y squared, and I need a y squared in my first equation, we're going to go ahead and use substitution. If we let y squared equal 9x in our first equation, we'll have 3x squared plus 9x equals 12. We go ahead and subtract 12 from both sides. We'll get 3x squared plus 9x minus 12 equals 0. And then we can try to solve this by factoring. Before we do that, we'd like to go ahead and divide through both sides by 3, since each of these coefficients has a common factor of 3. If we do that, we'll get x squared plus 3x minus 4 equals 0. This gives us some smaller numbers to work with. We can factor that as x plus 4 times x minus 1 equal to 0. We set each factor equal to 0 and solve. Will give us x is equal to negative 4, or x is equal to 1. We need to now use these values in our second equation. If we use x equals negative 4, we'll get y squared is equal to negative 36. Since there is no real number that we can square and get a negative value, this has no real solutions. If we let x equal 1, we'll get y squared is equal to 9, which gives us that y is equal to plus or minus 3. So we'll get two solutions here. Our two ordered pair solutions will be 1, negative 3, and 1, positive 3. When solving systems of nonlinear equations, it's often helpful to kind of get a visual idea of what's going on before we actually try to solve it. In this particular case, our first equation is actually the equation of an ellipse that's centered at the origin, and our second equation is the equation of a parabola that's open to the right. So if we think about what situations could happen, if we have an ellipse, the parabola opening to the right could miss the ellipse, and so we might get no solutions. The parabola might also just touch part of the ellipse, right there at the vertex, or one of the points along the minor axis. In that case, we would get one solution where they just touched. Another possibility would be if the parabola has a vertex that's inside the ellipse. And in that case, we would get two solutions. And we saw that that's what happened in our particular problem. We had two solutions. It could also be the ellipse could be inside the parabola. We'd get no solution. So there are quite a few different possibilities, but it helps to get some idea of how many solutions we could have. It looks like we might get no solution, one solution, or two solutions. In our case, we ended up with two solutions.